and welcome to another video for the Edexcel Further Pure 1 Maths A-Level syllabus. This is our sixth and final video on coordinate systems, and it's where we talk about how to work out tangents and normals to parabolas and rectangular hyperbolae. Right, looking at the scheme of work first of all, we've done everything required. We just have to finish off with tangents and normals to a parabola and a hyperbola. And we're going to need the technique of differentiation here. We're going to have to be able to differentiate the Cartesian form of a parabola and a hyperbola, and we're not required to know parametric differentiation, which comes up in Core 3 or Core 4. Okay, next let's take a look at the big idea you need for this topic. You need to know the following for this topic. This is Core 1 knowledge, so I'm just going to quickly recap it. There are some students studying FP1 and they haven't finished the Core 1 course yet. Right, imagine you have a curve. Here's your axes, your x-axis, your y-axis, and you have a curve that looks something like that. Imagine you want to know the gradient of the curve at the point xy. That's the point x, that's the point y there. The gradient of the curve at that point is defined to be the gradient of the tangent that touches that curve at that point. That is defined to be the gradient of the curve at that point, the gradient of the tangent. Now, the technique of differentiation works out the gradient of the tangent at the point for us. So if our curve is called y, then if we work out dy by dx, then that tells us the value of the gradient at the point x. And in particular, if say we wanted to work out the value of the gradient at the point x is 4, we would work out dy by dx and we would substitute x is 4 into the expression. Now, if you're not sure on the technique of differentiation, I have a Core 1 recap video in my Core 3 list. But effectively, for the work you're doing, all your curves will be polynomials. There'll be something like x to the power of n. And when you differentiate this, you end up bringing down the power and reducing the power by 1. nx to the n minus 1. So for example, if you're working out, if you wanted, let's pick a particular curve, our curve is y is equal to x cubed, and you wanted to work out the gradient of that curve at the point x is 1, you would work out dy by dx first of all, which would be 3x squared, and then you would do dy by dx and you would substitute x is equal to 1 into it, and you would get 3. The gradient of that curve at that point would be 3. That's the big idea we need for this topic. The other big idea is you need to be able to remember the normal to the curve. What is the normal to the curve? Well, the normal meets the tangent at right angles. The normal meets the tangent at right angles. And so if this would be called the normal, and this is the tangent. The one fact that you're expected to use on several occasions, and this is a fact that comes up in Core 1, if I call the gradient of the tangent m1 and I call the gradient of the normal m2, the gradient of the tangent multiplied by the gradient of the normal should always be -1. Or if you want to find, say you rearrange this, if you want to find the gradient of the normal, it's -1 over m1. It's the negative reciprocal of the gradient of the tangent. So if I told you the gradient of the tangent m1 was 3, you would know that m2 would have to be -1/3. If I told you that m1 was equal to a half, you would know that m2 is -2. If I told you the negative reciprocal, if I told you m1 was equal to -1/4, you would know that m2 must be its negative reciprocal, which would be equal to 4. And that's the big idea we're going to use in these questions. 1, to find the gradient of a tangent at a point, you differentiate and evaluate the gradient function dy by dx at that point. And 2, the gradient of the normal is perpendicular to the gradient of the tangent, and their gradients are inverse reciprocals, are negative reciprocals of each other. Right, I'm going to do some examples. You have all the theory to try these questions, but you may want to pause the video, try them, and then watch me go through them and make sure you understand these. These are the type of questions that come up. Okay, example 1. The point P where x is 2 lies on a rectangular hyperbola h with equation x, y is equal to 8. Find the equation of the tangent, find the equation of the normal to h at the point P, given your answers in the form ax plus by plus c is 0, where a, b and c are integers. Always, always, always draw a picture, no matter what. So I'm going to draw my picture over here. We know a rectangular hyperbola looks something like that. Okay, and it would have equation xy is equal to 8. Now we're told that P is at the point x is equal to 2. So x is 2 is here, the point P here is when x is 2. What would y be at that point, out of interest? If you substitute x is 2 in here, 2y is 8, so y must be 4. Okay, so that's the point P. We want to work out the equation of the tangent at that point and the equation of the normal. So we want to work out the equation of this line here, and then we want to work out the equation of that line there. Okay, right, let's do part A. To work out the equation of a line, you need to know the gradient of the line and a point on the line. We know a point on the line is 2, 4. We don't know the gradient. Let's differentiate the curve to find the gradient. So we know xy is equal to 8. Let's always make y the subject of the formula. Y is therefore 8 over x. Y in index form is therefore 8x to the power of minus 1. Now if we differentiate that, dy by dx, you bring down the minus 1 and you reduce the power by 1. So this would be 8 divided by x squared. So that is the gradient at any point. In particular, what's the gradient at the point 2? dy by dx, when x is equal to 2, will be 8 over 2 squared. So this should mean a minus here. It will be negative 8 over 2 squared, which is 4, which is negative 2. So now, let's do a line here. I could work out the equation of the line because I know a point on the line, P is 2, 4, and I know the gradient of the line, M is negative 2. So I can use the formula y minus y1 is mx minus x1. So y minus 4, substituting, must be negative 2, x subtract 2. Okay, expand this bracket, y subtract 4 would be negative 2x plus 4. And maybe add 2x to both sides and subtract 4, I would get 2x plus y subtract 8 is equal to 0, and I have it in the form ax plus by plus c is 0. A is, let's just state it, 2, b is 1, and c is negative 8, and hence I have found the equation of the tangent. Okay, now let's work out the equation of the normal. Okay, so the equation of the normal for part B, I'm working out the equation of this line. I know it goes through 2, 4. I also can quickly work out the equation of the gradient of the normal. I know that the gradient of the tangent is equal to negative 2. So the gradient of the normal is its negative reciprocal, and it would be a half. And I know point P is 2, 4 lies on the line as well. So y minus y1 is mx subtract x1. Y subtract 4 is a half x subtract 2. Multiply both sides by 2. I don't want fractions, remember, I want integers. 2y subtract 8 is x subtract 2. And then maybe subtracting 2y for both sides and adding 8. 0 would be equal to 8. X subtract 2y, and then plus 6. And there is your equation of the normal done. Right, I'm going to do another question. Maybe you want to pause the video, have a go, but then make sure you work through my solutions. As always, you must draw a picture. It makes life so much easier. So we have two distinct points A and B, where x is equal to 3 lie on a parabola with this equation. Right, straight away draw the parabola. Let's just draw the thing, because otherwise we're going to get ourselves confused. Now, just firstly, for part A, let's just write y squared is equal to 27x. Okay, and we know that a general equation of a parabola is y squared is 4ax. So 4a must be 27. So therefore a must be 27 over 4. Okay, so you've got the point here, the key point here, 27 over 4, 0, and this is the line x plus 27 over 4 equals 0. Now, we don't know if we're going to need those yet, but we might as well draw them in. It doesn't take much work in to draw them in. And the parabola will look something like this. Okay, so that would be y squared is 27x. Okay, it says that when x is 3, a and b lie in the parabola. So x is 3 would be somewhere about here. 3. Okay, they lie in the parabola. Let's call that one a, and this one here must be b. The line L1 is a tangent to C at A, so L1 is a tangent, like that. And L2 is a tangent at B, like so. Now, by symmetry, this drawing isn't quite right. You can imagine they must both cross at the same point here, somewhere there, by pure symmetry. Okay, find the coordinates of A and B. Well, that's easy for part A. I know that x is equal to 3, so y must be, well, y squared is 27 multiplied by 3. Y squared is 81. So taking square roots, y is 9 or negative 9. Therefore, A is the coordinate 3, 9, and let's call it B is the coordinate negative, is the coordinate 3, negative 9. And that's it, I'm done. Okay, draw a sketch showing parabola C. Indicate on your sketch the points A and B and the lines L1 and L2. Actually, you've done this part already. So this is 3, 9, and this here is is 3, negative 9. So that's positive 3, negative 9. And it's as simple as that. Find, for part C, an equation for L1 and an equation for L2, given your answer in this form where A, B and C are integers. So what I'm going to do, I'm just going to, for just ease, it's always helpful to have that picture. So I'm going to take that picture so I can keep in my mind what's going on, and I'm going to paste it here. Okay, and what we're going to do is we're going to find the equation of L1, and L1 is this line here, and L2 is that one there. Okay, now we need to know the equation. We've got a point on the line L1, we've got a point on the line L2. You need the gradient of the tangent at L1 and the gradient of the tangent at L2. And we need to differentiate the curve at that point for that. So we know that y squared is 27x. Taking the square roots of both sides, y is therefore plus or minus the square root of 27 x. Now I could break this up into y as plus or minus. I could just keep that with the root 27, and I could break that into root x. Therefore y is plus or minus square root 27 x to the power of a half. So the gradient function, if we differentiate dy by dx, keep the plus or minus root 27 there. Okay, bring down the power of a half and reduce this power by 1. And that there or maybe if I tidy it up, plus or minus root 27, I could say over 2 x to the power of minus a half. And that is the gradient function. Okay, well I want the gradient at the point 3 and at the point 3. So let's just make a copy of this page. So I know this is true here. I'm going to actually just rub this out to this point here. You should have that written down. So I know dy by dx is equal to this thing here. Okay, now I want to work out dy by dx at x is equal to 3. And that would be when I substitute in 3 here. So it's plus or minus, I'm going to get two answers, plus or minus root 27 over 2, and then x to the minus a half, that's actually 1 over root x, which when I sub in 3, it would be 1 over root 3. Now, when I type that in my calculator or use surds here, I would see that this gives me this will give me the answer plus or minus 3 over 2. So this one here must have a gradient, just looking at it, is a positive gradient. This one's gradient must be 3 over 2, and this one must have the gradient negative 3 over 2. Now I can find the equation of the normal, the equation of that tangent and that tangent quite easily. So I'm just going to rub this bit out here. Remember, dy by dx is plus or minus 3 over 2. Okay, so we know the equation of a line is y minus y1 is mx minus x1. Okay, let's do it for the two different ones here. Let's do it for this one here, L1. It would be y subtract 9 is 3 over 2 x subtract 3, multiplying everything by 2 to remove the fraction, and then multiplying the 3 in the bracket. Get 2y subtract 18 is 3x subtract 9, and then subtracting 2y for both sides and adding 18, I would get 0 is 3x subtract 2y plus 9, and I'll be done. The other one here for L2, well, I know that y subtract negative 9, because it's negative 9, would be negative 3 over 2 x subtract 3. So that would be y plus 9 is negative 3 over 2 x subtract 3. Times both sides by the 2 and multiply the minus 3 in the bracket. 2y plus 18 is negative 3x plus 9. Add 3x to both sides, subtract 9. I would get 3x plus 2y plus 9 is equal to 0. And I found the equation of L1 and L2, and it's the form requested. And I'm done. Okay, next question. Again, you should be able to pause the video, have a go, but I'll go through it. Make sure you understand all of the work I'm doing here. So, next question. It says, the point P with coordinates 3, 6 lies on a parabola with equation y squared is 12x. So y squared is 12x. We know the general equation is y squared is 4ax. So in this case, this tells us that a in this case must be 3. Okay, I'm going to quickly draw that before I read the question too much. So this point here we know is 0, 0. We know a key point here will be 3, 0. And we know this line here, x is negative 3, will be a key line. It will be the directrix. So the curve looks something like this. Okay? Right, y squared is 12x. Always draw a picture. Okay, find the equation of the tangent to C at P, given your answer in this form. Now, P is the point 3, 6. So P is this point here, which I'll maybe colour in a different colour. That's P, and it's 3, 6. Okay, and they want the equation of the tangent, so they want the equation of that line there. That would be the tangent. I might give it a name. I might call that L1. Okay, now to work out the equation of a line, you need a point on the line, we've got that, and you need the gradient of the line. We can get that by differentiating the curve. So, if y squared is 12x, then y is plus or minus the square root of 12x, taking square roots of both sides, which I can write is plus or minus root 12 root x, which I can write as plus or minus root 12 x to the half. Now, for L1, this gradient here is positive, so we know we're going to take the positive sign for this case. So take positive, just take positive root 12. So y is root 12 x to the half. Therefore dy by dx is root 12 over 2, bring down the power of a half, reduce the power by 1, and that's dy by dx. And I'm actually just going to, if I just highlight this here and make this a little bit smaller, I might have space here. You should work down the page, but I might just have space here to fit this in here. Okay, so that's your dy by dx. You want the dy by dx at 3, so you want dy by dx at x is equal to 3. What's the gradient at the point 3? You substitute 3 in there, and you would get yourself 1. So the gradient at that point is equal to 1. Therefore, using the formula y minus y1 is mx subtract x1, y minus 6, you get y subtract 6 is 1, x subtract 3, y minus 6 is simply x subtract 3, and we want it in the form y equals mx plus c. They've asked us in a different form here, i.e. make y the subject. Y is therefore equal to x plus 3, and that's it, you're done. That is the equation you were after. Done. Okay, there are 2 more questions now. These questions are very similar, they're using the same techniques, however we're using algebra, more algebra and less numbers. So you should be able to have a go at these, but if not, work through my solutions. Here's example 4. It tells us that the point P, at squared 2at, lies on a parabola with this equation. You'll remember x is at squared and y is 2at, that's the parametric form of a parabola, and they give us the Cartesian form of the parabola as well. They haven't told us a or t, and or t at any point, and they're saying show that the equation of the normal at P is this here. So this is an algebraic problem here. A little sketch, just as always, to see what's going on. This is the point A0. This is the line x plus a equals 0. The curve looks something like this. Okay, the curve is called y squared is 4ax, and any point on the line show that P is the point at squared to at. It's some point on the line. It could be up there, it could be down there. They want to ask you what is the equation of the normal at P. So if you'd have to work out the tangent, and then you want to work out the normal at P. Okay, let's start off simply. Let's start off by working out the equation of the tangent. So we know y squared is equal to 4ax. So if we take square roots, y is therefore the square root plus or minus the square root of 4ax. Y is therefore equal to plus or minus root 4 root a root x, and y is therefore plus or minus 2 root a root x, and I might write that as y is equal to plus or minus 2a to the half x to the half, so I can differentiate in a second. Told that P had coordinates at squared and 2at, assuming T's numbers like 1, 2, 3, 4, and A is positive, we're told that, then P must have a positive x coordinate and a positive y coordinate. So I'm going to forget about the negative here, and I've drawn it with positive. I'm just going to say y is equal to 2 a to the half x to the half. So what's dy by dx then? We're differentiating with respect to x. 2a to the half is just a constant, okay? And differentiate this, bring down the half, reduce the power by 1. Okay, so just tidying that up, dy by dx therefore would be a to the half x to the negative a half. Right, we want to work out dy by dx at the point x is equal to at squared. So I'm going to just draw another line here. Could actually just, right, so we want to work out dy by dx when x is at squared, right? So that would be a to the half, and that would be at squared to the negative half, which would be a to the half over at squared to the half, which would be a to the half over a to the half t, and then the a to the halves would cancel, so it'd be 1 over t. So that is the gradient of the tangent. Okay, I'm just going to rub this bit out for now. So the gradient of the normal is a negative reciprocal, so the gradient of the normal must therefore be the negative reciprocal of this, which would be negative t. I know the point on the line is at squared 2at. I know the gradient of the normal now, so I can use y subtract y1 is mx subtract x1. So y subtract 2at would be negative t, x subtract at squared. So y subtract 2at, multiplying it out, would be negative tx plus at cubed. And then adding the tx to both sides and adding 2at, I would get as required y plus tx is equal to 2at plus at cubed, and that is what I'm asked for up here, and I'm done. So again, it's a fair bit of algebra in this case. Draw the picture. Remember that the gradient of the normal is the negative reciprocal of the gradient of the tangent. Get the gradient of the tangent by differentiating and putting the value of x into the gradient function. Okay, last example. We're told that the point P, CT, C over T, where T is not 0, lies on a rectangular hyperbola with the equation xy is equal to c squared, where c is a positive constant. Show that the equation to the tangent at P is this. Right, quick sketch. We know what a rectangular hyperbola looks like. Looks something like this. Okay, the equation is xy is equal to c squared. We are told that the point P, CT, C over T, where T is not 0, lies on there. I'm going to assume T is positive again, and I'm going to say there's a point here, P, which is CT, C over T. Remember, that's the parametric form. X is CT, Y is C over T. That's parametric, and here is the Cartesian. It's given us both. Show that the equation of the tangent at H, tangent to H at P is that. So we want to work out the equation of that tangent there. Okay, so we know a point on the line. We just need to know the gradient of the line. So we know that xy is equal to c squared, so y is the subject of the formula, must be c squared over x, so y is therefore c squared x to the power of minus 1. Differentiating dy by dx, c squared is just a number, it would be negative c squared x to the negative 2. Okay, and if you want to work out that at x is ct, if you want to work out the gradient at the point x is ct, you substitute ct in here. Remember, this means negative c squared over x squared. You would get negative c squared over c squared t squared. Okay, the c squares would cancel and you get negative 1 over t squared. That is the gradient of the tangent. Right, I'm just going to shrink this here. So they want us to work out the equation of the tangent. Well, we're going to use y subtract y1 is mx subtract x1. So y subtract c over t is going to be negative 1 over t squared x subtract ct. Now multiply everything by t squared. We don't want fractions in our answer, so multiply both sides by t squared. You get t squared y minus ct is equal to negative x minus ct. Expand that out, t squared y subtract ct is going to be equal to negative x plus ct. And if I add ct to both sides and subtract and add x, I would get x plus t squared y is equal to 2ct, and that's exactly what I was looking for, and I've got the answer. The next part says, I'm just going to make this a little bit smaller here because I think there's going to be a lot of drawing on this one. It says that a rectangular hyperbola G has equation xy is 9. The tangent to G at the point A and the tangent to G at the point B meet at negative 1, 7. Find A and B. Right, let's draw a picture to see what's going on. The focus here, if this is xy, so xy is equal to 9, looks something like this, doesn't it? So this is the equation, xy is equal to 9. It says the tangent at point A and the tangent at point B meet at negative 1, 7. So negative 1, 7 might be somewhere up here. Okay, so this is negative 1, 7. Now the tangents to the curves meet here. The only way I can envisage that happening is a tangent somewhat like here, approximately, and the other tangent would be something quite extreme like down here or something like that. Okay, so that's the only way I can envisage them meeting. So therefore, let's call this point here, we're trying to find this point here, let's call that one our point A, and this one here must be our point B. That there is where they meet, and it was at, remember, negative 1, 7. Okay, we don't have much information. We don't know what A or B are, okay, their x or y values, and we don't know what t is at those points. We know nothing about A and B. We have to find that out. Now what we do know from part A is we were dealing with a curve xy is equal to c squared. And we worked out that the tangent at such a curve is given by the equation x plus t squared y is equal to 2ct. We know that. Okay? Now, in this equation, in this question, we are dealing with xy is equal to 9. So therefore, this tells us c must be equal to 3. Right? Because c is a positive number. Negative 3 would not be negative 3. So therefore, any tangent to this curve must have this equation, but where c is 3, so must have equation x plus t squared y is equal to 6t. Therefore, for some t, that is the equation of this tangent, and for a different t, that would be the equation of the tangent. The one thing we know about these two tangents is they go through this point here, negative 1, 7. So you can substitute x is negative 1, y is 7 in, and that will tell us what t works, what t makes that tangent go through that point and that tangent go through that point. So subbing in negative 1, 7, get negative 1 plus 7t squared is equal to 6t. Okay, this is a quadratic, make the right hand side 0. 7t squared, subtract 6t, subtract 1 is 0. And trying to factorise 7t, t here, it would be negative 1 and plus 1 is 0. Okay, so therefore, there are two possible values for t. T is therefore 1 on one hand, or t is equal to negative 1/7. So they're the two t's for this graph. Now, we know that any point on the curve has equation ct c over t, but we know for, let's say, point A, we worked out before that c was 3, and that's the one where x and y are positive, so therefore we're going to take the t as 1 for that one. If we substitute 3 and 1 in here, then A must have the coordinates 3, 3. Now for B, C is still 3, but T is negative 1/7, so therefore A would be 3 times negative 1/7, which is negative 3/7, and then 3 divided by negative 1/7, which is negative 21. So that was point B. And they are your A and your B as required, and we're done. So that's all for this video, and that's all for the entire section on coordinate systems. Thank you for watching.